Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, thanks for coming back. We swapped the order of Kurt Bourne and Alex Gray. So now it's my great pleasure to introduce Alex Gray, who's going to tell us about scalable data mining.
All right, thanks George and the organizers for having me here. So my affiliation is a little different now. For those of you, it's the usual suspects plus some others. For those of you who know me, I'm still at Georgia Tech, but spending most of my time now at Skytree, which I think is a new company. Not that new in a sense. It's been a developing product for 3 years, which is machine learning, scalable machine learning software. So a lot of what I'll talk about, all of what I'll talk about and will ever talk about, is implemented in Skytree, or will be. And so that's what I've decided is the final delivery form for all the fast algorithms and stuff that my research lab and the other labs that I cherry-pick the best of, fast algorithms and machine learning methods from, they'll be in Skytree. So why is that interesting to you? Of course, I have a special sweet spot for astronomy. It's how I grew up. It was my domain area that I worked in. I'm not an astronomer. I'm the maybe the one guy in here who's not an astronomer. Who else would describe him or herself as a non-astronomer? Okay, all right. But I'm a computer scientist / machine learning or statistician. So I'm an oddball in the sense that in the last 20 years, probably the person who's been hanging around astronomers the longest that I keep seeing today. And then within machine learning, I'm an oddball because I'm the guy who's been worrying for a long time about big data. And of course, now it's a hot topic. In the last 2 years, a lot of other people have started to think maybe this is important. But for whatever reason, the software we have today to do this stuff is the same. It's the same crap that we've had for 20 years since I got started. It's the same general framework. You have a library written in some language. You do need many different tools because there's no one tool that does everything. And then, but you have some thin command line interface, and you can do some plots. Okay, that's MATLAB, R, Weka, SAS, SPSS. It's both commercial and open source stuff. There's really nothing still. There's some attempts that are pretty weak still. And if you ask me, pretty, like really weak, like not usable, weak in the open source world. It's great, but so what we've decided to do is kind of take the best in the research world that we know of in algorithms and machine learning methodology and cook it into real professional enterprise-grade software that both a big company with a lot of money and or a science institute with almost no money can use for their high value, high complexity problem. Okay, so anyway, that's all I'll say about that. But if you're interested or intrigued, both we need people to work for us who are smart, including astronomers, and also making it basically as free as we can make it for astronomers. Okay, so if your institute or group is interested, let me know. So astrostatistics problems, here's some common ones that I'll talk about. So the first four, these boil down to, so I realize a lot of what people end up being interested in after my usual talks are kind of the steps that I skip over, which are, well, what's the best way to translate my problem, first my science problem, to a machine learning problem? And then once I've done that, like which type of machine learning problem. Once I've done that, which method should I use? So I'm going to talk a little bit about that, a bit of more of a tutorial way. Many of you here are already experts in that, but for those of you who might get something out of that, I'll talk a little bit about that. And then at the end I'll come to these last three, which are so the first four really boil down to there's a kind of usually a straightforward translation from the problem to a machine learning formulation, but then the issue is computational, and that's what I'll say a little bit about in a slightly different way than I usually do. And then the last three are basically statistical issues where the standard machine learning methods out of usual software or textbooks don't quite do the trick. You need the fancy stuff or something fancier. So, well, what are the different kinds of tasks? Basic queries, estimating a density, classification, regression, dimension reduction, clustering, and two sample testing and matching, comparing two data sets. Okay, I think most of you kind of know what these are. You know, this is the usual starting point for my talk, which is, yeah, if you look at these actually, and you look at the best ones, they're n squared or n cubed often. And I will come back to that. That's a killer. N is the number of rows in your data table. So n squared is a crushing growth in computation. That means you can't do millions, let alone billions of objects. And then, of course, that's just for one run. If you of a method with one setting of a parameter, you actually want to try many settings of parameters to get the best model. And to get error bars, which we never get to this point because of computational reasons, we would like to do the whole thing 10,000 times to do a bootstrap or a jackknife. Okay, so we never even get that far because we're crushed just trying to do one run of a sophisticated method. And these are just textbook methods. They're already difficult. Okay, these are non-textbook methods. These are more state-of-the-art methods that these are just examples from my group. But there are many of these. The fancy stuff that is the stuff you make up to deal with specific problems, like whatever, measurement errors or whatever. These are even more expensive, typically. Okay, you want higher sophistication. You see even an n to the 4 here. Okay, because higher statistical sophistication means higher computational cost. Almost no way around it. So that's the computational problem. So, which I'll come back to. But for now, I want to, this is probably the most common kind of question that I get, which is, well, so I translated my problem to a density estimation problem, let's say. Density estimation is basically like a histogram is a density estimator. It's non-parametric. It can fit any shape of distribution. It's one-dimensional, and it's kind of crude because it's choppy. What's the fancier version of that? Well, it's kernel density estimation. So many of you know what that is. It's smoother. It's in general dimension. It just fits the shape of your distribution, and then you can now probe that shape and go, where is it low? This point, is it low is it a low density point or an outlier? Is it a high density point or common point? And so on. So, of course, this is fundamental. We want to do this everywhere in astronomy. So, what's the best way? There's kernel density estimation. There's also a mixture of Gaussians. Those are probably the two that I would suggest. So, for this problem, they have different, what are the trade-offs? Kernel density estimation is your most accurate overall method. It's free. Why is that? Because it's free of strong distributional assumptions. It doesn't have a lot of parameters. It has one parameter that controls a scale, basically, of a little kernel function that you throw in each point. But it's killer. The reason it isn't used everywhere is that it's expensive, unless you have a fast algorithm. So, which I'll come to, of course. I work a lot on that. Okay, but if you don't have the fast algorithm, the real fast algorithm, the best one, is pretty complicated, unfortunately, for this. So you really want it kind of packaged up in some reliable software. Mixture of Gaussians, tried and true. It's pretty efficient. Use something called the EM algorithm. It's pretty efficient once you have a fixed k, where k is the number of Gaussians that you fit. Of course, the problem then is how many Gaussians do I fit? I kind of want to make it more and more non-parametric, or able to fit arbitrary shapes that aren't necessarily really just big Gaussians. And so I can throw more and more Gaussians, but then how many, and how do I search that space of Gaussian parameters and number of Gaussians? That's what makes it fiddly, unfortunately, meaning you have to try a bunch of stuff. And the other thing making it fiddly is that you obtain local minima in the optimization. It's not a global optimizer. Nobody knows how to do a global optimizer for it that just works. So it's a non-convex problem. So, but it has another advantage. It offers a way to impute. Imputation means filling in, guessing at missing values. So if your data table has a whole bunch of question marks in it, well, this measurement was not taken for this. We don't know the ellipticity of this object. No one recorded that, or whatever, question mark. You have a whole bunch of holes in your data table, then the usual algorithm for this, with EM algorithm, can fill those in. It can guess them for you. Whether that's good or bad, it's better than nothing, because if you don't fill them in, you can't use any machine learning method. Machine learning methods assume generally that everything is filled in. But they're still kind of an open problem, basically, because you are kind of putting in data that isn't really there. So ideally, your learning method would learn the model simply ignoring those question marks. They don't affect, it only uses the non-question marks to obtain the model. Okay, but that is possible in certain methods, certain situations, and that's preferable in my opinion. So I don't think missing value imputation is the end of the road for, it's not totally satisfying. Nonetheless, if you have a problem right now and you have missing values, this is a good thing. It's decent. Okay? So those are some trade-offs there. Classification is the other one I'll spend time on. That I won't touch on all the problems, regression and all, unless you want to ask me about them later for lack of time. But there's a whole zoo of methods, especially for classification. It's the one machine learning problem. In a way, it's the hallmark machine learning problem. It's the one that the most effort has been put on. It's the one that's easiest to understand what it's doing. It applies all over the place. And it gives good results. It's the basis for most of the big results that application results that have come out of machine learning. You could say, Google uses machine learning to show you ads, which ads you might like based on your query terms. Handwriting recognition that's in the U.S. postal system. 97% of all mail is done by machine learning. All of these big things are classification under the hood. Okay, so but that's why there's so many of them, and there's so many different ways to kind of sit around and dream up a new classifier, new kind of classifier. So how do we navigate that? So Naïve Bayes is probably your simplest. You could teach this to a kindergartner, as long as they know what a Gaussian is. It's simple, and therefore it's instantaneous as far as speed as well. It's also instantaneous to implement. Those are both good things, but it's unlikely to ever give you the highest accuracy. It's a very simple model. Logistic regression is probably one level up in non-simplicity, but still pretty simple, pretty fast. It's a linear classifier. Perceptron is a different way to do a linear classifier. You may have heard of that from the 80s. also unlikely to give you the highest accuracy because it's a linear model. Your decision boundary that defines what, the boundary between cloud of class A and cloud of class B has to be linear, perfectly linear for this to be a great model. So decision tree, now we're starting to get into some powerful methods. This is non-parametric, which means you can prove, actually only in a shaky way, but roughly it's still true, that you can fit any distribution, any decision boundary with this kind of thing. Unfortunately, it's also a little crude. It's kind of choppy. It's like in the sense of a histogram. It chops things up into hyperrectangles. But it has a lot of great properties other than it gives you medium level accuracy, a lot better than these other two generally. But you can interpret the output as rules. And so one of the earliest kind of machine learning things in astronomy I was semi-involved with was at JPL doing a star galaxy classifier with decision trees. And back then, they were looking at the rules to interpret what are the properties of objects that make them more star-like or galaxy-like. Okay, so, and it's somewhat fast. It's not instantaneous, but kind of fast. It's n log n to learn, n log n time, where n is the number of rows. You can easily do mixed, discrete, and continuous attributes. In other words, some of them are numbers, numerical. Some of them are A or B type variables. It has a way to do missing values in a nice way, actually, that doesn't impute them. It doesn't guess at the missing values. It actually just ignores them. It only uses the non-missing values to make its model. And it automatically, all at the same time as learning the model, it decides what features it can ignore that actually weren't useful for making the, which is the other big thing you always want to know. Okay, you have a model. What were the features that actually predict if something's a star or galaxy or quasar or non-quasar? Okay, so that, a lot of nice properties, but still not the highest accuracy generally. We do a lot of these bake-offs in machine learning. It's kind of part of the culture, which I like, empirical bake-offs. And it never really is the winner, but it has these nice other properties that are very practical. Okay, then there's random forests. So people who were champions of decision trees didn't like that other methods were pounding decision trees in accuracy, and so they found ways to boost the accuracy of decision trees in a way that mostly keeps most of the properties but that are good, but then you lose one at least. So what you do is you basically take a whole bunch of decision trees and you average them together. So you have to learn hundreds, maybe ideally thousands of decision trees. They're all a little different, and the way you make them, a couple ways you make sure that they're a little different from each other. And then you average them. So then the model is some linear combination, essentially, of many decision trees with equal weights, generally. But it's a huge model, of course, and so you can't interpret it anymore. But it retains the other good aspects of decision trees. And the accuracy now is in that set of methods that can give you the highest accuracy. Okay, so I'll just say I won't pick a winner as far as accuracy because there's never one winner across all problems. It is problem dependent. There's even a theorem about that, the no free lunch theorem, which says there's no winner across all problems. It depends on your data. But although in the winning set, these are all methods that are non-parametric, meaning you can prove that they can fit any decision function. Okay, and this is one of them, random forest. Neural networks, there was a time when all of machine learning was neural networks. It was synonymous with neural networks, a couple decades. Now it's been reborn as something called deep learning. Well, it's really the same thing. It has always been poo-pooed. It got poo-pooed big time in the mid-90s because something displaced it in popularity called support vector machines, which will come next. Because support vector machines, basically you can learn in a convex, it has a convex objective function. So you have a good optimizer for it. Whereas problem with neural nets is that it's fiddly. It's another one of these non-convex objective functions, and so you're always stuck in local minima. It has thousands of parameters usually, and there are all sorts of things. So you end up but if you work at it, you can get state-of-the-art. In fact, for a couple problems, neural nets are the best approach, and so that's always the case with any method. If you're dedicated enough and dogmatic enough about that method, you can make it the best method for your problem because you put more energy into it than anybody else. So, and there are some important problems where neural nets, deep learning, are the biggest things. And relevant to this community, image problems, image classification problems, some of them, neural nets deep learning is the best thing right now. Okay, speed, slow-ish to train, but fast at prediction time. So kind of medium, kind of like decision trees on the scalability front. Nearest neighbor, very simple method, but among that set that can give you the highest, accuracies. And my favorite for certain astronomy problems is kind of, you could say, an elaboration of nearest neighbor, kernel discriminant analysis. I like it because it is in that set that can give you the highest accuracies. It just has a few parameters. It's expensive unless you have a fast algorithm. If you do, it's okay. And it has interpretable probabilistic semantics, which people like Bayesians and other people who want to think about probability distributions like and feel comfortable with in terms of interpretation. And it gives you an accurate estimate of the probability of being in class 1 or 2, which many of the other methods don't focus on that. And so they don't give you good estimates. Okay. And then the support vector machine, actually anecdotally, across all problems, if you had to take one winner, averaged over many, many problems, what's the most common winner? It is the nonlinear support vector machine. No, usually by just a little bit, but if you had to pick one winner, this would be it. Unfortunately, and this is the biggest open problem of my lab aims to scale up all machine learning methods. This is the one that I can't really do yet. This is the thorn in my side. So no one can do this yet, basically, make it scalable. If you could, it would be the one to use in terms of pure accuracy, okay? So I just want to say, if you look at this list, and you want to focus on the non-parametric ones, the high accuracy ones, these are the ones in red. Well, why are they expensive? Why are they in squareds and in cubes? And many of you know this, if you know my research. It's because they involve all pairs computations. They're comparing each point with each other point, computing a distance or similarity between them, or kernel. Okay. Recently, there's this National Academies report on massive data. It's finally become a topic of national interest, and so I wrote the chapter there looking at the deep computational bottlenecks in analysis of massive data. And these problems tend to be of this second kind, which whose category name I made up, generalized n-body problems, things involving pairwise comparisons. For those of you who don't know this, and I usually don't say it this way, but this is my provocative claim. Anything to do with pairwise comparisons, I believe we know how to make it from n squared to order n. We've done this, I think, for all of the common things that you see in statistics. Okay, that, for example, for every point, find its k nearest neighbors. That's n squared, naively. Order n. This is all provable now. It took me many years. We now prove this is provable in the computer science sense of worst case complexity, which you may not care about, but computer scientists always told me, this is just a conjecture. Prove it. So we finally proved it. And it is a little non-intuitive, which is why it took me a while, why it is that you can do this in order n time. Okay, but my claim is if you're looking, it looks like you're looking at something with pairwise comparisons, you have to do them all, you probably don't need to. And this includes things like friends of friends, includes endpoint, where it's even worse. Endpoint correlations are pairs in the 2-point case, or triples or quadruples in the higher order cases, okay? And so we did the first fast algorithm for general endpoint that's exact a long time ago, 2000. But now, smarter people than me, like my student Bill, who I'm going to promote in this talk, have done the largest 3-point, I've continued, it's even faster now, largest scale 3-point correlation to date, which is published. And actually, when you're doing, in practice, when you're doing endpoint calculations, you're using a random set, and you're doing many, many resamples. You're doing a jackknife, and you're doing it for many, many scales, right? Many matchers or scales, right? If it's 3-point, it's many different triangle settings. So it turns out you can do all of them at the same time in less time than doing all of those things individually. And you can get many orders of magnitude speed up by doing that. It's another paper that Bill did. This is with Andy Connolly. Okay, so real quick, statistical issues that come up, measurement errors, big issue because some objects are close, some are far away, so they have different measurement errors. So we're working on how to do some of these fancy non-parametric things that are based on kernel density estimation. We have results that are about to come out in a way that accounts for measurement errors. 3 more slides. And then everything is now time domain. So all the next generation surveys, and so you would like to be able to do all of this stuff, not just on static objects, but where each object is actually a time series. The problem with that is time series are variable in length and so on. So they're not of the same shape. So, but there are ways to do machine learning, which is standard paradigm is everything is of the same shape, a fixed length vector, on funny objects that are not of the same shape at all, like graphs, sentences, and time series. So we have some ways to do that. And then finally, even though we can do certain sensors a large scale all over the sky, still there are other more expensive ones that we can't do all over the sky on everything. So the question arises, what are the best objects to measure? This is sometimes called active learning. So if I only have a fixed budget of objects to measure to obtain some underlying function of something, then what should they be? So that, it turns out, surprisingly, it's a natural concept to formalize, to want to formalize. It's been a long time, very recently, people have done this in a rigorous way, where you can prove that by not choosing everything, and not choosing everything randomly, but in a deliberate way, you still get some guarantee on the error, right? Because if you only choose some of them in a funny way, you could just learn the wrong function. But there's a way to, and we probably did the other way to do that. Okay, so I'll just mention the software implements all of these things. How do you find out more? As the last slide. If you want to find out more about how to do machine learning in astronomy, there's some other good books out coming out, and we have one with these co-authors where we'll have a longer expounding on these kind of tips and tricks for what sort of methods should I use for my problem, as well as explanations of them. If you want scalable software to do this stuff, where do you get it? It's not scalable, but there's Python code in our book that makes machine learning easy. There's scalable serial software, one machine software that's free, open source from my lab. And then, of course, you want the fastest and most powerful. That's for pay, but we'll make you a deal, you and any scientist, basically, to support science at cost. So just talk to me directly if you're interested in that. And if you're interested in both, the upcoming expert is my student, Bill, who works in astronomy in doing scalable astrostatistics. And if you're interested in machine learning as a career, talk to me about we need smart people at Skytree. All right, thanks.
Thank you. Okay, questions?
have the microphone and a soapbox. I have to disagree with your characterization of kernel density estimation.
Okay.
I'm attacking the characterization of kernel density estimation as you said it's the most accurate. It actually throws away information. Any smoothing technique, of course, discards information at the finer scales. In a sense, the trade-off is you want pretty pictures of your density rather than accuracy in some sense. I didn't have time to talk about it, but the Bayesian block algorithm I described in one dimension can work in higher dimensions. And I referred to a paper with Mike Way as the senior author where we apply that to the Sloan Digital Sky Survey and basically get a density estimation that essentially represents all the information that's present without any bias at scale and doesn't do any smoothing. So.
Okay, well, certainly open to there being many methods that are good, but I'm not sure how you can do any kind of density estimate without smoothing, because if you're not...
tessellation does it in order n in a simple way.
But that's a discretization, which is a form of smoothing. In fact, it's a chopping.
Well, in this context, the data is discrete anyway, so you're just representing the density information in the data.
Okay, so if it's discrete data, then you can use a discrete method and not smooth. But if it's continuous data, you have to do some smooth. I think that's... But anyway, not that there aren't other methods, but these are kind of... I just listed... standard off-the-shelf textbook methods. That doesn't mean there aren't fancier methods from the research literature that should be in the textbooks. So.
Okay, full question.
Oh, maybe David's question?
Yeah. So one distinction you alluded to in your talk but didn't make explicit is the difference between generative models and not generative models. So some of these, for instance, just specializing in classification, some of these techniques are effectively a generative model for the data and then use that generative model.
Yeah.
And I think from the point of view of astronomy, there's a lot of advantage to generative models over non-generative models, because in generative models, you're better able to deal with missing data, which I consider to be an absolutely essential problem for astronomy. You can deal with the fact that you have heteroscedastic things and so on. But more importantly, to this community, I think, in this room, is there's this issue of utility. So whenever we're classifying, we're always classifying for objectives. We have objectives, and those objectives, we don't necessarily want the most probable results. We want the results that produce the most value for us going forward. They select things for follow-up or whatever. And I think that somehow that's missing in this thing about classification. It's not clear to me all where you can insert your utility into these.
Yeah, so you hit a number of things, which I'll try to remember and address. So, generative versus discriminative. Yes, typically you get a couple of things extra out of a generative method that you don't get out of a discriminative method, usually at a cost, at the cost of being the very most accurate. The discriminative ones usually, they do less work in a sense. They're not trying to get you class probability estimates. And those, if those are really important to you and you want them to be accurate. So that's why I like things like kernel discriminant analysis, as I said. But you do pay a little cost for that, and that's why a kernelized support vector machine, which is discriminative, is slightly more accurate in general, because it only worries about the decision boundary. So, but as another, you could say, advantage of probabilistic or generative methods is the missing value thing. But that's only one way of doing missing values, which I cautioned about, which is by imputation. So that's not the only way. It has some pluses and minuses. So I wouldn't necessarily tie them together in a one-to-one fashion. Oh, you have missing values, you have to go do a probabilistic method. Not necessarily. But yes, you often do want a confidence on, I called this thing type A instead of type B. What's the confidence of the model? That's pretty common. You can get those out of a discriminative method, but it's usually a hackier way of getting probabilities out. So it just depends on the relative importance of all of those things. and then in your application. And then utility, there is a formal way to put utilities on top of machine learning. It's very simple. You just, in your decision function, you can eventually write any machine learning method, if you know the basics enough, as a Bayes classification task, in terms of Bayes formula. It doesn't mean you have to be a Bayesian, but you just write in terms of Bayes rule. And then you can throw utilities into that formula. And thus you can say, well, if it's more important to me, for example, to make errors when I call type A things that are really type A, I call them type B, versus calling truly type B things type A, that's one form of utility that's it's not equal weights in the errors. That's easy to adjust for in putting utilities around the overall loop. And there are other ways that you can put utilities into things. So I don't know if that addresses everything, but.
Well, for instance, in the kernelized SVM, is there a straightforward way to include utility?
Straightforward, no. But that's why I said if you know the basics well enough, you can essentially rederive all of the methods in a way that you put in utilities into the parts that you care about.
That would be a valuable contribution for science.
Well, let me know if there's an interesting or particularly common instance of that in astronomy. That's something we could do.
Okay, last question, Eric.
I'm not sure if I'm asking the same question as David in a more naive way, but David very quickly mentioned heteroscedastic measurement errors. So in a table, multivariate table, every cell has its own personal measurement error. My question is, do any methods, my belief is almost none, but do any classification methods or other methods allow these to be taken into account?
Off the shelf, no, and this is of course a huge issue in astronomy.
Is that the same question you were talking about?
Well, no, but I do have I do have a similar answer, which is,
This is a grand challenge level need. Because astronomers spend a vast amount of effort measuring their measurement errors, and then they go to the statistician, and there's nothing but 1901 chi-square, which is just pathetic in its capabilities. And so there's a huge disconnect between the practice of observational astronomers and the availability of the modern methodology to incorporate it into the methods. So this is not a trivial issue when you ask about measurement errors, and I'm not sure, how closely it is related to your point.
I consider it completely related because, for me, missing data is just an extended case of measurement errors.
Yes.
Your missing data is just a point that has a very large.
We have missing data, which is sometimes a truncation and sometimes just missing. And we have censored data, and we have measurement errors. And in astronomy, the truncation, the censoring, and the measurement errors are all from the same source. And we have no mathematician who's willing to tackle this. I've tried to get you guys to work on it.
No, I won't work on it. Well, I'll just give you, I don't know if we have...
We'll come to it very quickly then.
Okay, so the rough rundown of the situation in the literature is that this was worked out for linear regression, and that's it, basically, in the statistical literature. This problem is called their errors in variables.
Yes,
so it's even got
books on it.
funky names and so on that make it hard to track down the
Useless.
it's kind of useless. So, and then there are two cases of it, which homogeneous errors and heterogeneous errors. So we could, of course, we're interested in different errors on different points. Even that has even less work on. So, so now, but we want to do this now for fancier all machine learning methods. Unfortunately, the way to you have to rederive each one from scratch. Basically, it takes a new method, a custom method, and so we're trying to do that for a certain class of methods. David's done that for a certain class of methods. So they exist. There are a few things coming out, but it basically takes custom development of new methods. It hasn't really been done in the stats literature or the machine learning literature.
Okay, I'm afraid we should call this discussion to a halt. I'm sorry, we really got to move on.
What's some practical things? Alex, none of your links from FastLab work.
Oh yeah, I keep hearing that.
Okay. Thank you, Alex. So, into the panel discussion with George Zukowski, Yanshu, and Mike. Yes. Talking about towards new models of scientific publishing. Over to you guys. Sorry.
All right. Well, may as well start. So, for years we've been all kvetching about the need to reinvent scientific scholarly publishing enabled by information technology. And there are two aspects to this. The first one is that the variety of scientific product has increased dramatically, whereas it used to be more or less just research papers in journals. Now we have all manner of other stuff that's very much intellectual product, whether it's data archives, algorithms, workflows, just simple ideas. People debate interesting things in blogs, etc., etc. And I think, first of all, we have to develop a system for acknowledging and collecting all of that worthwhile product in a meaningful fashion, and also figuring out the new model for quality control. Because we have a peer review system which is effectively broken because there is too many papers and not enough time, and essentially it's more used for people to undermine their competitors than to advise colleagues to do something better or nothing at all. So we need to look into that through forms of maybe crowdsourcing or whatever. The second aspect of all this is that we're simply not using technology to deliver whatever content we want. That most of the stuff that we do mimics printed paper, which is crazy. That we need to think of native electronic publishing that has nothing to do with ink on paper and can link to different varieties of digital products, media, movies, simulations, whatever, in novel fashions. Doesn't have to be structured as traditional papers. And then we have to convince community to embrace all this.
Right. So speaking of that, George and I have, I think, I was reading this book that we put together like several years ago. We called it Computational Education for Scientists. So in 2007, that was the first conference I called at Microsoft Research, and there were like 3 astronomers in the room among other professionals who's keen on promoting computational education for scientists. And then we also talk about a new way of publishing ideas. But we've been talking about it since then, for the past several years. And then a lot of things has changed. First of all, 2 years ago when I was doing the same thing with, putting together a book for the conference, the first criticism I got when at the opening of the workshop saying, oh, we're going green, we shouldn't print them anymore. Mm-hmm. So I'm totally for we do a online electronic version. And which is good for not only publishing the papers, results, and data, and mostly promote ideas. And now the question is, if the community is not into it, then we may have a few content show up and then not sustainable without a group of people dedicated to maintain the quality, like George was saying, and then keep on having new content from different disciplines. So I'm here to listen to you for ideas, and I can go ahead and then perhaps implement some mechanism, at least to start from Microsoft Research to support the community. But I need people to, a few at least, die-hard people who's gonna, devote it to, and then keep this going. So again, I can have a sign-up sheet, whoever wants to be the victim of the first group.
Okay, first I think I'd like to say that I'm very unhappy that Lee Dirks isn't here to be on this panel.
Yes.
I think that's all I want to say, but I miss Lee Dirks. Mm-hmm. Astronomy for the past 25 years has been building publication mechanisms and libraries completely independent of the journals and the old structure. I'm going to list several large entities that are all 25 years old or so, and you'll see how that works. ADS, CDS Simbad, NED, the Archive, CADC, The main archives, let's call them Einstein and Chandra or ST-MAST or the ESO archive. It's interesting that all three of those were founded when Riccardo Giacconi ran those organizations. The HESARC, the IPAC, the European Space Agency has several, the Super Archive, etc. That's where we're spending our money. The amount of money going to those dwarfs the money that's going to the journals or to our journals plus all the libraries combined. We've already decided to move away. We've already doing it. Maybe it's time to formalize that better, but we're kind of leaders in that field among many of the scientists. So for something new to publish, I just thought I'd say one thing that seems to me obvious, and it's very short forms, things that don't really belong in journals the way journals are structured, but need to get out quickly, like a graph or a table. Very often, a result is one graph, one data table, and all the paper around it is just, getting that out. The people who understand it will understand it just looking at the picture. And why wait 6 months to write it? Why not put up the picture? We don't have a mechanism for that, and that's the mechanism I would most like to see. So I think that's enough to introduce.
Mm-hmm.
Yeah, over the coffee, we've been banding about how maybe we should start a completely novel journal of AstroInformatics along the lines I talked before, fully digital, different media, experiment with all kinds of things, including peer review. And I assure you, exact same discussion happens on e-science conferences in general. So there are two problems here. Some people need to devote serious time to actually start and run such a thing, in our copious free time, right? And some institution needs to sign up to it. And I mean respectable institution, not like those mushroom journals that are popping up all over the internet. They're essentially vanity publishing. That stuff's irrelevant. And okay, you can say, well, there is this new journal of astronomy computing, and I appreciate good intentions, but I'm sorry, I think that was exactly the wrong thing to do. Because it's A, paper journal of old style, and B, it's going with commercial publisher. And I think that commercial science publishing is already dead, they just don't know it yet. Just like newspapers, just like the old music industry.
Can I make a comment on that? One of the problems is that some of us need to continue to build our careers. And in order to do that, we have to publish papers and get funding. And then
Did you say career? Build up a career? Yeah.
And so we're graded on where we publish to a large degree. And so, we can start up our own little journal, and that's wonderful. And no one's going to publish in it because,
Exactly.
You want to get that job, you want to get that promotion, you want to encourage your students to publish in top level journals and so on. What may be may not be possible, but a better avenue is to talk one of the existing well-respected journals into having a branch that they try some experimental thing, and so you can piggyback off the reputation of that journal, but still try these new things. So, should we be getting people from those journals along to these kinds of meetings to get them excited and get them thinking about how this might happen?
That's a really good idea.
Yeah.
That's a really good idea.
This is what George was saying.
Yeah, but this one is exactly
So that's
comes out of the open astronomy, I think.
That's an answer to my question I just posted on Facebook. If you would mind, go comment. Yeah, I just posted that question, and you provided the answer, at least one way of.
So what's your question?
My question was, how can we come up with a mechanism to, provide incentive and encourage that? And you can't just ask people to do it and then creating a career problem for them. They will have an identity problem when they graduate if a student is doing that. Where do they go, right? As an editor, as a physicist, as a computational science?
It's like these online courses that Harvard and Princeton are putting up. It's a different way to get an education that's piggybacking off the reputation of an existing infrastructure. And maybe there could be an avenue that way.
Yeah, consider Physical Review X.
Yeah, exactly. Right. Yeah.
Okay.
I'm here. I've got the editor's hat on for that journal. agree, and have long agreed with most of the doubts that George has. And I've expressed exactly the same opinions on a number of occasions. The thing is, the journal has a very key property, which is missing from other things that George mentioned, and that is the property of actual existence. It actually does exist.
Actual
existence. It is accepting papers and will publish. In every other respect, it's a very boring journal. It looks very much like old journals. So it takes a lot of the reputational boxes that you mentioned. And that was very deliberate. We weren't trying to be experimental under any heading other than getting this community a journal. And the question of trying to piggyback on other journals, we thought of that as well. And before we started this, we were in touch with the editor-in-chief of the big three astronomy journals and various other journals. We sent them some ADAS abstracts and said, what would you do with these? Would you drop them on the floor, or would you at least send them to the referees? And the big three said, drop them on the floor. Even A&A, which has a section on which purportedly covers this, said, well, that one maybe, fine, but the rest, basically not. And basically they said, we're not interested unless you can talk about the astronomical results coming out of this technology. Just technology is not interesting. So the journals that did say, well, maybe, were journals that were, to be frank, a little bit too keen to take anything.
And yet those journals will publish survey design papers.
Right.
Or instrumentation papers. What's the difference between hardware instrument and a software instrument?
Well,
right?
I agree.
Exactly.
I think it would make perfect sense for these journals to publish these papers. But they said no. They didn't say no, maybe.
I think this is an aspect of the great cultural shift problem that we've been talking off and on through the meeting. In this case, applied to journal boards or editors. But maybe the better approach is to go not through astronomy, but through e-science community, which is much bigger than AstroInformatics and has exact same issues, and probably does have a critical mass, which I'm not sure about AstroInformatics, to actually do something. Start a respectable journal within respectable society that will deal with these issues, especially if they have universal importance, like this is how we deal with such and such data analysis problem or database problem, and so on. Maybe that is a more viable way to approach it. Then maybe someday there will be UpJ e-science supplement or UpJ astroinformatics supplement or something like that.
So I'll just comment a little bit and then switch to you because we talked about this last night. My comments with a negative perspective saying that what value do you provide to the rest of the community if you bring it to e-science? Why would a bioinformatics read your journal? So that was quite negative. And this morning I thought about it. I guess we can position it the other way. If we wanted to join the e-science community as a branch of AstroInformatics, maybe that's a way to push us to think more broadly. And then when we publish it, we really want to focus on the general aspects of computational challenges.
You know, people who build instruments,
value to the rest of the community.
People who build instruments might read optics journals, but general astronomer will not read an optics journal.
It's just a different matrix to measure this. I'm sorry. Yeah.
Well, I was just somewhat following up on this comment of PRX or AppJ comps, AppJ AstroInformatics. Recognizing the serious issue of careers,
right.
I think one should give some really serious thought of, is there a way to change something like AppJ letters into an AppJ experimental or some more experimental aspect of AppJ? I've certainly written to the AppJ letters editor and said, I don't think this paper should be published in AppJ letters, because you might as well just put it in the main journal and then post it on AstroPH as soon as it's accepted. That's way faster than AppJ letters. So the letters, and that's, I'm picking on AppJ, but I think at least a couple of the other big four have a letter section. figure out a way to do away with the letter section, because that's outdated, and move it to this more experimental.
Well, once upon a time, they may still have this statement, but APJ letters had in their instructions to authors that they were accepting papers that had no lasting value. Like, wait a second.
Right.
Since we are talking about science fiction,
Speak up.
we are talking about science fiction, about dreams, let's say, about things which need to be implemented from scratch. Now, very stupid question. We have something which already is in place, where all of us send our paper, which is AstroPH. It is not refereed. Wouldn't it be easier to transform AstroPH in AstroPH version 2? So basically, you submit your draft, then AstroPH takes care of the refereeing process. Then, when the paper has been refereed, you get the flag, which is what we want, that this paper is refereed. And then you have also an automatic way of measuring the impact on the community of the paper, not of the journal, by looking at the number of downloads and eventually with the number of feedbacks. This is an idea, I must be honest, which we discussed with Omar already many years ago. I mean, how to get a feedback from the community, which is the equivalent of the Facebook I like. I mean, to tell the truth, I don't enter into a library since many years. And also, I love IDS because for historical reason there is everything there. But usually what I do, I go to IDS. I find the new papers which in which I'm interested. I try to download that. They are protected by the copyright of the journal. I go to AstroPH and I download it from AstroPH. So basically, all our reading of astronomical journal is through AstroPH. Now, what is the reason for the proliferation of this journal? We all want to reach the astronomer. We want to reach the computer science. There is a computer science section also inside the xarchive.org, so it should not be difficult to do the things. Well, because to be in the scientific board of a journal adds prestige. I don't know. I don't understand the proliferation of a journal. I have been member of several scientific boards. Well, my career didn't gain anything out of it. We don't need to have the support of a big community like IEEE or like, or American Astronomy. I was thinking about this last aspect tonight. We already have our board which creates consensus. It's the whole community which cannot live anymore without AstroPH.
The way high-energy physics normally works now is you submit to AstroPH, you let it stay up for about 2 weeks, people complain and write you back, you change the paper, and then you submit it to the physical review, which allows you to submit it by sending an AstroPH number, and they download it from AstroPH, from archive themselves. So high-energy physics already has a rather different model in that respect. The editor of Physical Review D told me once that he reads papers when they're on both, when they're already up in the journal, he still reads the archive version instead of the PhysRev version because it's 1 click rather than 2 on Spires. That's the editor of the journal, so everybody else does too. There's plenty of statistics that show that.
Question over there.
Chenzo?
Jen. Give him a mic.
For professional
Yeah.
journals, I suggest maybe we should.
Yeah, for our journals, I suggest maybe we should do some survey for users' requirements. If we meet the users' requirements, maybe we can get better performance or better or much successful. For example, for Chinese community, for scientific journals, we have some basic requirements. A journal has to be indexed by the major index system, for example, the ICI and the EI. Yeah, open access journals are very popular for some countries, but for Chinese users, they are not popular. The main reason is that most open access journals are not indexed by ICI or EI systems. For us, or maybe for graduate students in China, even though you publish the 10 papers or even more on the new created the computing journal, but it is not useful at all for you to graduate or to get a promotion. So another example is for the proceedings of ADAS and the proceedings of SPIE. They are quite different because ADAS proceedings are very useful for our software developers and VO developers. But we are not eager to publish or to submit papers to ADAS because there is no use for us for promotion. But for SPIE proceedings, because they are indexed by EI, so we are happy to publish our papers, to submit papers to the SPIE meeting. That's why for the IU symposiums, because they are indexed by ICI, so many people, or maybe from China and maybe from other countries, they hope to submit one or even more papers to the IU symposium conference. So that's my opinion.
So maybe, I mean, that's essentially Darren's comment. I think that you need some formalism, like being indexed by ISI, something like refereeing, or maybe replacing refereeing. It doesn't have to be refereeing, but you've got to have some process which ensures a minimum standard.
No, those are two different problems. There is respectability problem, and there is effective peer review problem.
Yeah.
And I think what Pepe was alluding to, some form of crowdsourcing effectively should be a peer review.
That was too fast. No, I was saying, just ask AstroPH to add a refereeing mechanism. You submit your paper and people can begin to read it. Meanwhile, it is refereed. Then after, if it is accepted, there will be a light or a green light on the paper saying it has been refereed and accepted.
Perfect.
Yeah.
AstroPH will never change because Paul Ginsberg never wants to change anything.
That's right.
And they don't have resources. And moreover, they're just rapidly disseminating the old style papers, right? The word paper tells you the problem. We're so used to ink on paper.
Yeah, I am the referee for instrumentation and methods for all of AstroPH. I read the titles and look at the authors, and normally that's enough. Somebody does look at every paper before it goes up. It's an undergraduate assistant, and if it doesn't meet the form of a paper, has references and all that, it's flagged. I have to look at it. If it's a poster or something, it doesn't go up. They're not willing to put things like that up, as George has pointed out.
If I can just make one comment on the refereeing process, what some other disciplines, particularly the humanities, do is they've abandoned the formal refereeing because they couldn't get people to referee papers, and they do effectively have a crowdsourcing thing. So they post the paper, they invite comments from other people, and then some editor at some stage reviews the comments and gives it a go or no go, or the paper needs to be revised. So there are other models already out there. Eric.
I've been an AppJ editor for 7 years, one of 19 scientific editors, and to a considerable degree I serve this community in the sense that astrostatistics and astroinformatics papers often are assigned to me. So I actually play a role as the traditionalist in the room, and I'm now going to give you my opinions that are not official opinions of the Astrophysical Journal, but they're mine. First, you should know that the AppJ and the AJ actually do accept astroinformatics papers. There's some informal sort of feelings that we don't like what are called code manuals. We don't want to see how the code, how to run the code. But if you describe the methods and then have an appendix on the details of the code and apply it to some example and show that it's useful, then we will accept it. Our criterion is new and significant research in astronomy and astrophysics. And there's no statement that it requires a telescope or physics. It can be pure instrumentation and pure informatics.
So if somebody...
However, despite the fact that this is true, your community, this community here, doesn't seem to, it doesn't seem to work. In the sense, very few submissions are made on codes or informatics. So few that you don't even know what I just said, because it almost never occurs. So sociologically, it is failed. But by policy, it's still a problem. And that's my first thing. My second comment...
Sorry, can I just ask you, so clarification, so would you accept somebody writing a paper about a new algorithm without actually applying it to any data?
No.
See, that's the problem.
Yeah, but it's not a big problem because we don't have very high standards about the application. So if you apply it to a piece of a junk problem, you know, it doesn't have to be an innovative result. It just has to show that it applies to some star or galaxy, or some image or some time series or whatever you want. So we have low standards on the application, but we require Section 4 to be the application.
Okay.
And this is informal. This is not a formal requirement, and maybe you could convince us to change our sort of style on this. It's informal.
Right, that's what I was going to say. Do you regularly revisit the matrix, the rules that you use to? For example, you may learn something from this community. Yeah.
It's informal. Would it be useful for us to formally state this in the scope of the journal online? Would you then use the journal more? Yes. Because almost nobody is submitting it.
Then you catch up. We match.
See, that's the problem. This discussion is going in the wrong direction. We're not in a need of a new journal. We're in a need of a different way of publishing that can contain...
That's my second point. I'm talking about the traditional journal, traditional paper articles that are now online. Okay, now PDF articles. Okay. My second point is about AppJ letters. And again, this is a personal interpretation of discussions that I've heard, etc. In my opinion, and the opinion of perhaps some others, AppJ letters has lost its original purpose. The original purpose was to be fast. And the reason it lost it is because AppJ used to be 10 months, is now 10 weeks. AppJ is as fast as AppJ letters used to be. Okay? And that's all technology. It has nothing to do with it. So all the delays in AppJ are not due to the editorial process. Okay, it's due to the authors. So
well, it's when the author puts it up.
Admittedly, AppJ letters is maybe 7 weeks instead of 10 weeks. There's some small difference, but it's very small. So there's actually discussion that AppJ letters, having lost its purpose, is purposeless and should be. And I actually had hoped that there would be a change of purpose in the last change of editor, which just occurred, which, due to lack of courage and frankly lack of consensus of lack of good ideas and lack of consensus, no change was made. You should know that the world, some people, the AS Pub Board and the editorial boards, don't like the situation of AppJ letters, and we sort of want a new purpose or something new. So if there's anyone in the room who has actual new ideas within the context of AppJ letters, we're not going to become a blog, okay? I mean, it's just not going to be totally different. But in the context of a traditional journal, if you see ways of innovating, I think you should send your ideas to Ethan T. Vishniak, the editor-in-chief. I think actually he's looking for ideas. I don't know that, but I think this.
Before we go to other comments, can I ask the panel?
All right. First, I showed a whole bunch of plots yesterday, with the exception of the one where the fish pond fire plot, which was an SPIE. All the rest were in AppJ, AJ, PSP, and AppJ letters. It's quite easy to publish these things if they're part of some sort of scientific thing, as astronomical thing. Most of them were just software paper. The eigenvector paper is just pure software. There are a couple of different directions that we can talk about. One is making the current publications computable, which they're not, and the other is publishing things that are outside the realm of a 10-page paper. George is suggesting the second. I was thinking the first, but they're both ways that are pushing non-traditional things. The journals have not been very good in either of those things in leading. It's one of the reasons why there are 20 new libraries and publications method over the last 25 years, none of which are the journals and none of which are the traditional libraries. What to be built, I don't think that modifying the AppJ letters is really what George thinks is important, and I don't either. I do think that making the papers computable is important. And that, I mean making it so that computers can understand what the papers are, and that requires work in publishing. It is, it makes it so that papers can't be free. It sort of goes in the other direction of open access. Dense semantic tagging is one of the catchphrases for that. Symbat, of course, does that already. The librarians at ST do that already.
You have to talk to the technical people on this. I don't know.
We do that. It's one of the things that ADS is looking at with librarians. But that goes in a different direction than making publication faster and toward what people are actually doing. And I think that's what George is talking about.
Well, one of the things, but maybe...
Can we have Jan next?
I want to say that other than the content and the scientific outcomes for a journal, there is other things that you have to worry about. The political, even the political impact, the social impact, and administrative and the logistic running of running a journal. So we should not invent another journal. That's not what we're here for. We're talking about new ways of publishing. If there is already existing a vehicle that we can use, we should take that vehicle to a different path that matches what we want for today's publishing. So that should be the direction of this discussion, other than creating another vehicle.
George, do you want to add?
Well, that's exactly right. We're so brainwashed into thinking in old format style, papers in a journal, that this discussion veered in that direction. Let's improve APJ letters. No, that's not the problem. The problem is exactly what Jan said. Want to be able to publish scholarly output of different kinds, that you can publish a data set or an archive without having to write a bogus paper around it, right? Or I ought to be able to publish one paragraph idea saying, this is a good idea, somebody should do this, I don't have time, and somebody might do it, and maybe they'll cite my little digital thingy somewhere, right? I want to be able to publish numerical simulation or an algorithm or a workflow. Given Sloan's survey and this survey and that survey, this is how we discover high redshift quasars. So there is no result, right? There is, it's not even code, right? So that's what I think we need. The only reason why I started new journal is because the old journals are, I think, hopelessly wedded to the paper paradigm.
Okay, we've got a zillion questions, so we'll start at the front and move backwards. So, Alex, Matthew, Ashish.
Just throw out a couple things. So, in a field like mine, which is about methods, we have an issue that everyone feels uncomfortable about, which is...
Oh, sorry, one use one.
You can read a paper about a fancy method or algorithm, but then when you try to implement it, all the details aren't there. You don't know if it's... All right, the experiments that they showed aren't really reproducible. You don't have the data set. You don't have the code. So, which gets to the issue of publishing code and data sets and idea all at the same time. In fact, it should be a requirement that you can't publish an algorithm unless the code is there so it can be verified. So we don't have reproducibility in methods, basically, the methods part of the world. And the same would be here if we opened up astronomical publishing to methods more. So that's one thing. The other thing is this, building on Pepe's idea about AstroPH. So what if there wasn't, instead of having a green light yes or no acceptance model like we have in publishing today, we simply have a continuous, like you said, like a dig style thing where you put something up there. It happens to be my area. I read it. So one problem we have in computer science is getting enough of the experts' time as reviewers. You get some reviewers, but it's almost always you don't have the right people because they're busy or whatever. But you can get their attention if on the topics that they're really interested in. So you publish something, I go, oh, I like that topic. I want to comment on that, and I'll rate it in the 4 areas or whatever: novelty, depth of experimental results, and whatever, and then it has my name on it. It's not anonymous, and so if I'm well known, then that has more weight. If I'm not as well known, it has maybe less weight, and so that creates a kind of formal point system for for, maybe that's all we need to forget about. It just becomes an
well, sorry, can we, let's move up the room and we'll get to you in a second.
So I would like to suggest that some of this is actually already being solved by a broader scientific community. There's a little journal called Science that some of you may have heard of. And there are, I can think of 4 papers that I've downloaded from Science in the last year, which are specifically about methodologies, new methodologies for doing informatics type analysis. And you have the paper, which is the summary of the method, and then there's a thing called the SOM, which is supplemental other material, which are more in-depth descriptions of the algorithms, greater details, attached data sets, attached results. Sometimes there's attached code as well. And it strikes me that a lot of what we're trying, or a large chunk of what's being suggested, has already been solved by a major journal out there, and that's the sort of thing you want to be looking at.
I think that, I'm sorry, just immediate reaction is that that's still different from what George says. We're going to publish fragments.
No, I agree, but there is part of it has already been done where you are trying to. I don't have I can't reproduce your results, or I want to know more about this, or where's the code attached to it.
It's optional, right? So very few people do.
The 4 papers that I've looked at in depth have got it, and it was very useful to have that information. But you make it a stipulation that if you're publishing, that's what you want to be doing.
Yeah, I do agree with this part that we should start doing that more, that add code to it, add a data set to it, and make it reproducible so other people don't have to come back to us and say, how did you do this? I'm not getting the same result. If they run the same code on the same data set, they should be able to do that. And so that I would agree. And to what George said about being able to publish a paragraph and so on. So what's wrong with doing something like that on the existing things like AstroPH, for instance? Why do we need something? And some people do that.
David does it a
No,
lot.
yes. No, but there's no connection to formal points, basically. You can post whatever you want. But, I think if we just establish a way that it just shows you some points.
No, but then are we asking about policing it? And then who would do it?
You've got several different issues in there.
Yeah.
Right.
Okay. Pepe, Norman, Nick, Eric.
Everything. I mean, absolutely agree with what Gray said. The problem is that Eric, I mean, you're just going the wrong direction. In my opinion, I know I'll start a fight on it, but I think the RPJ, the Montfiniers, are exactly the wrong way to go. It's the wrong way to go, because basically they cost a lot of money for reasons which are no longer understandable, since most of the subscription are to the electronic journal, and therefore there is not anymore the huge cost of a paper which there was in the past. They are just a system of power. While nowadays we see a world which has moved toward consensus platform like Facebook, selecting. So it is just a matter of doing things intelligently, because to assign a referee, I've done a few times in my life to assign a referee to a paper. You basically look at the quotations, you find the paper which is quoted first or more time inside the paper, or the paper who is on the other group, and you send the paper to that guy. I mean, it's basically a system of power which is self-perpetuating itself when technology offers hundreds of different solutions. I don't see why there must be a monthly notices, an astrophysical journal, or astronomy computing with different areas. Well, basically, you have a system of keywords which electronically allows you to pick up the article in which you are interested. If you want to have a almost automatic system of reviewing or choice of a referee done with a simple algorithm, by selected member of the community who will be willing to contribute, then you can get a traditional refereeing, or you can get a referee or together done by the community, like the one which Gray I were mentioning and so on. I think it's just obsolete. Then, furthermore, an approach like this, AstroPH based, obviously, since the guy is paranoid about these things, it will not be AstroPH, it will be something different, but something ResearchGate-like. It's something which I like very much. Then you can publish programs, Not like it happens very often that you say the program is downloadable and then for 2 years you cannot download it for reason which is the program must be downloadable. Then you can download data. I think it's so simple. I don't see where the problem is. Besides a political problem to solve the mafia of the various journals.
Norman, next.
I'm very much enjoying this discussion because over the last year and over this afternoon, it made me more and more convinced that getting involved with this journal was the right thing to do. And I've intelligibly a variety of points here. The question about why can't people publish small additions, like a table, a paragraph. They can already. They can do that now, and that would work tomorrow if people could get professional credit for that. If people could list these in annual reviews, in CVs, that would work now. There's absolutely nothing stopping that, except politics. It's true that journals are dead. They were dead 10 years ago. That was obvious. But they have manifestly not stopped twitching. And I see no reason to expect they'll suddenly stop twitching in the next decade, because it's unintelligible to have lasted this long. So it's unintelligible to claim that they'll suddenly stop. And it's all these discussions about archive overlay journals, about completely new models, open publishing. I've heard all of these for the last 10 years in bars, cafes, lunch breaks, at conferences, and nothing has happened. A generation must die, fine. And this is a social problem. It's a social problem.
Max Planck said that science progresses one funeral at a time.
And I will run out of list of topics in a moment. I can keep going.
Actually, it's Eric next, but first of all, does the panel want to respond to anything?
Well, I think now the discussion is moving in the right direction. I think maybe we can clarify our thinking by parsing the great problem into several smaller pieces. Mm-hmm. One of the reasons we have journals at all is the archival nature of it, that somebody has signed to perpetuate this stuff forever. And usually some professional society or a really successful commercial house like Nature, right? And so that's a whole other thing. Somebody needs to really make that commitment and pay for the upkeep, right? Now, as far as we contributors are concerned, there is an issue of, well, broad variety of types of contributions, which we really haven't addressed properly. The issue of quality control or peer review, which we may be able to crowdsource, or each paper can have a little wiki associated, and so all of the reviews, minus the obscene ones to be removed, would be there forever. And then there is a separate issue of giving people credit for this new variety of publications. And so there has to be some agreed upon standard way, it could be DOI, it could be something that people can put in their publication list, that they can be cited as, as such and such suggested in this electronic thingy, or we use the data or the program or the workflow from, again, giving electronic reference. So, and that those count. So then that really means if enough professional societies decide this is the way to go, then Institute of Scientific Information will have to just learn how to count those. You can count downloads. You can make, linear combination of number of things, number of downloads, positive reviews, negative reviews, whatever. So, but that's a different story.
So we've got a whole queue of people. Do either of you guys want to add anything to that?
I just want to share how I feel. Yeah, I agree that we have this kind of discussions over and over again, like I was showing the book that we did, 2007. I was thinking of when I was 10 years old, I was talking to a friend of mine. She started collecting stamps when she was 5. So I envy her had that stamp book, beautiful stamp book with dragon stamps and stamps from UK, from other country. I was thinking, oh, I'm already 5 years later than she did, so probably not a good idea for me to start. If I started back then, I'm already having, I don't know how many beautiful collections of stamps. So I don't care what kind of things we're talking about, as long as we can kick off something. form that we can collect ideas and then get it going and then revise it, that would be a great outcome of this conference.
Mike?
All right, to the point of money.
Yeah.
It costs about $5 for something to be up on archive, and it costs about $2,000 for things to come into one of the reputable journals. That money isn't wasted. So you have to decide what parts of it you want. I won't go any further than that, except that the money isn't wasted. The whole refereeing and formatting and long-term saving of it is part of what that money goes for. The journals traditionally have not been the ones to archive the journals. It's been libraries. Libraries have basically collapsed. So the long-term archival keeping of the journals is only newly and temporarily in the hands of the journals, or handing it off to someplace like Portico. It's not clear that there's a long-term solution for electronic journals, but there is no other long-term solution. Paper is not the way anymore, clearly. I guess that's enough.
Okay. Just a footnote to this. I mean, I've been talking a lot to librarians, and there are very astute communities paying a lot of attention to these issues.
Yeah,
so there are a lot of clever people who are really thinking how to do that.
There's a good discussion at the IE on exactly that, actually.
Yeah.
Right.
Eric, Nick, Joe, Alex.
I just want to, this is very light, it's just an anecdote, and I thought, Pepe, you would enjoy it. Hearing about the mafia of the journals from you from Naples is very interesting to me. So now I want to tell you who the mafia are in some cases. So I'll try to disguise a little bit. There's a senior editor who's been trying to make an innovation that, by the way, I think science and nature do, to publish the numbers underneath graphs, associated with graphs. Okay? And this is an obvious innovation. It's quite easy for us to do technically. And it's been unsuccessful because it's been stymied by the higher level bosses called the AAS Publication Board, who are elected and tend to be very ignorant of the fantastically interesting issues that the people in this room are actually quite knowledgeable about in many ways. So just want you to know that it's not always the public face that you think who's the enemy. It's sometimes someone else.
As Pogo said, we met the enemy, and it is us.
Yes.
Yeah.
It's just a couple of quick things. So it's not perfect, but you could certainly imagine on your job application replacing list of publications with list of DOIs, some of which are publications, but it encompasses all the other stuff like code and whatever, as a way to compromise between being able to show everything you did and actually having something you can get credit for. The other thing is more of a question, is there's an initiative by Peter Coles in England called the Open Journal of Astrophysics, and the motivation of that was to basically let astronomers make their own journal. I don't know much about it, but does anybody have any comments on that?
Didn't go anywhere.
And they're focused on having it be free, not having it be open. It should be called Free Journal of Astrophysics.
But
Didn't go anywhere.
Are you saying it's already dead, or?
Basically, no one is using it and didn't take off forever.
Okay.
Well, it was only started a couple of months ago.
Yeah, but no. Longer than that.
Yeah, how is it different from archive?
Well, it's a journal.
Right. Journals produce articles which people look up in ADS, just like archive. It's how people really use it. So
I cite archive papers all the time.
Yeah.
And, why not? They're there.
And the ADS go search out all that.
Yeah, ADS makes the match anyway. So.
But archive, going back to where was the point it was, that when you're applying for a grant, at least in Australia, you actually have to list citations and impact factors. And unfortunately, AstroPH is no good for that. Archive's no good for that. Joe, I think
Could ADS help you by creating an impact factor for archive? It's easily calculated.
Oh, that'd be good, actually.
Yeah.
Oh, I'll do that. I can probably do that.
Fantastic. That'd be brilliant.
This may be the best outcome of this conference.
Yeah.
ADS would have an enormous impact factor if you did that.
Yeah.
Well,
And then we'll have
we have all the money we need.
So leaders, academic search.
Yeah.
complement that as well.
I may be repeating what others have already said, but I sort of think 90% of this problem has probably been solved in that we already have large tables in journals that are not printed. They're, you get the first 10 lines or whatever, and if you really are interested in the table of data, you go someplace else and you grab it. It's not obvious to me why we can't have appendices that are not published. There's a one-line description that if you'd really like to see the code, go here. Or if you'd really like to see this movie or set of movies or extracts of simulations, okay, it's not going to be in the paper part. It's got to be somehow stored elsewhere. But I think that the technology and the capabilities are sort of almost there with some of our major journals. And to provide this sort of curmudgeonly viewpoint here as well, George did hit on this archival notion. There is an important aspect that we shouldn't forget, that at times you do want to be able to go back to read the paper from 1970 or 1950, or at some point people are going to want to look to see what we were doing in 2012. So there is an important archival aspect to this as well that is not free and is going to be very challenging.
Well, while that mic is moving, let me point out that what you just described says that all of this new content is minor subsidiary to the traditional paper. What I'm pointing out is that there are new types of content that are good in their own right. If somebody wants to publish code, they should be able to publish just that code without the paper that it goes with, that kind of thing.
Okay. Two quick comments here, and then down to
I think what you're saying is not very complete, because he said exactly one paper on the archive costs $5, one paper in mid-journal $2,000 or something like that. Look, that this journal do not live only out of subscription. This journal live from contributions from main organization, from astronomy and astrophysics in Europe is largely paid by the government. They don't live out of subscription. And I think the same is true for monthly notices or astronomy. So if you just move to electronic publishing, a small fraction of what is currently paid by the government to maintain the paper journal will cover all the expenses for the running operation and for the archives.
But the 2,000 has nothing to do with the paper. The paper is almost free. It's all the rest of it is the cost.
As a very quick, almost point of information, A&C will, for example, support adding supplementary material to articles, and I think that's not the only journal that will do that.
Well, and science.
Yeah, exactly. And so the only thing that's stopping the vision, well, not the only thing, one of the other only things that's stopping this is the willingness of editorial boards to do something different with what they believe is a good article, an adequate contribution. And some editorial boards will be more conservative. Some editorial boards, e.g. this one, are still at the phase of saying, okay, what should this article look like? That was part of the motivation of this. It wasn't just to read in a journal, it's to ask the question, what does an article in this area look like? It doesn't have to be section 1 to 4. It can be anything.
Just briefly, if you have your software in the astronomy software library, the poster's over there, it is indexed in ADS.
Yeah. I mean, on George's point of why not just publish a code, the counter argument to that is, of course, the code is no good if you're not telling me why you're publishing it.
Yeah.
I mean, seriously, think about, could you go through a code, strip out all the comments, and publish that, and would that have any value to anybody?
That's a bogus example.
I don't think George really meant
That's not what I'm saying.
Exactly. So you need some kind of descriptive about it, even if it's only a paragraph. This code is
Sure.
going to do X, Y, Z.
That's not.
That's not the point. You want to write a full scientific paper.
Yeah, exactly.
To describe what the
reproducible.
manual describes. Publish the manual.
So I just want to throw out one data point from another field, which is a success story of how we upended the paradigm. So in machine learning, roughly 10 years ago, the dominant journal was called Machine Learning Journal, that they didn't let you own they own the copyright, and therefore you couldn't put the paper on your web page. They were actually sending people nasty messages saying you can't have that on your web page. So, machine learning community, you know, and this gets to that difficult issue. If you're trying to do something new, make something free, different paradigm or something, there's the reputation issue. That was the only place to publish if you wanted to have a reputable paper. So what happened, the way we resolved that was the leader of our field, basically the most famous guy, started the new journal. And so you need basically, once the famous people are all there, and now this new journal is the main journal in our field, JMLR. So you need the well-known famous people to all be behind it, and then overnight it can actually have the reputation. So it's not hopeless.
Okay, we're coming towards the end, so anybody else want to make a comment? Then I'll hand back to the panel for some. That's a silly question, wasn't it? Okay, 1, 2, 3, 4, and then the panel.
So regarding publishing of code, there already are some comprehensive archives, like R has the CRAN, the Comprehensive R Archive Network. Perl has the CPAN, which is the Comprehensive Perl Archive Network. So these are typically individual programs, well packaged, with documentation, with manual pages and everything. So would there be any sense for the astronomical ones to have corresponding DOIs applied to them? Or like the poster that is there, they have a good set of rules, what you can put in, how you can start, about a code snippet and so on. So that is also opening. When we are talking about a new journal, what is it exactly that we are saying? So how are these different from that? So can we somehow leverage these into what we are calling as fluid journal and so on?
Okay, let's pass the microphone.
This is a journal comment and everything, but just coming from the point of view of a earlier person career, I would like to kind of remind that almost everyone I think who's been discussing this so far is someone in a permanent position. Okay. Okay. I think that many people in this room are discussing this from the point of permanent positions. Okay. I think that meant. Okay. So, because it hasn't been explicitly said, although I'm philosophically very much in favor of everything we've discussed, I'm somewhat nervous about all of this as well, because I worry that when going for a permanent job, I know that there are many people who are not as broad-minded as the people doing this discussion, who, despite the fact, even if it works better than a traditional model, will slap down a rule and say, you only have this many AppJ papers, we're not going to consider this. And for younger people, I think that's an enormous consideration that we have to, even if it's a better method, there is pressure to put it in an AppJ article or a MinRes article.
But that can change. If you had an established journal which was recognised and doesn't need to be traditional, the main thing is it's got to be recognised and given time.
But on the other hand, if you join it now, when you turn into established, this journal could be one of your credit. Like my virtual stamp, in my dream, virtual stamp book, right? If I started 10 years ago, when I was 10 years old, I already have this profound kind of size of it.
But if we don't publish now in the old good journals, we're not going to get a tenure. That's the point.
Yeah.
If we try to publish on that journal, we would like to publish on.
No, maybe not now.
Most astronomers will look at that and say, what is this?
And that's okay. But that's not a reason for not starting it, though.
That's a separate problem. As I said, there is problem of delivery, there is problem of quality control, there is problem of giving credit. All of those are big problems.
Yeah, I think it's very complex, and it's probably worth looking at the sociology of all this, because in a certain way, it's a reshuffling of power. You have new methods, but the power of decision making goes much slower, the changes. So basically, it's absolutely right to hear students that will be skeptical about these new methods unless the power is sensitive to these changes. So the point is trying to look at these new systems and somehow create the right incentives, the people, so that the recognition and that it moves science in a better way. I think in a certain way, that's already happening with information. We Google, and some algorithm is making the decision of what we look into. And so it is beginning to happen that's affecting the power of decision making and the way that information flows. I think it's a very complex sociological problem that we should give a very deep thought. I don't think we have the answers, but we do have the right problem that should be addressed very seriously.
The students are never skeptical about new methods. They're skeptical about us, and that's a completely different thing, because it's for sure that this revolution will take place, because there is no other way. I mean, we cannot think that we can continue cluttering shelves of libraries, which cannot not even allocate any more space for this thing. This thing is going to happen. Now the problem is to understand how. I just wanted to comment on the story of publishing programs. Last year in Pucon, at a meeting organized by Eduardo, there was a fantastic talk by a guy from the image processing community who has solved this problem since many years. You just need to look what are doing others. They publish programs since many years with the templates, with the comparison, with the documentation. There is a standard for publishing program which needs just to be adopted, and not as we always want to do, to rediscover hot water wheel and this type of thing. Many communities have already done. Can I make a suggestion? I think that this discussion is very interesting and very useful if we can keep all the facets of the discussion. We have a Facebook page. Why don't we use it to put... Sorry? Whatever you want. Really, we have these Facebook books where every one of the people who contribute to the discussion can add their contribution, so that we can try to reconstruct. Because at the end, if I'm not wrong, everything goes down to build a proper business model. Because I'm sure that if we point out that using electronics rather than paper can save, to strangle the university, choke the university, billions of dollars, because it's like my university spends 1.9 million euros for the Department of Mathematics and Physics and so on in subscription. A model based on electronic publishing would save precious research money to our company.
So
it won't save any money. It simply won't save any money.
Yeah, I want to say that Facebook or email or any mechanism, I want to throw this question to the audience. What would be the minimum we can do to avoid having the same discussion next year?
Yeah.
It seems to me that we need to write a requirements document for the new model of scientific publishing, which will outline all of the problems that we have mentioned here. And then that can guide discussion about possible solutions. Some things may have been solved already. Others might require a completely new approach. Others may be unsolvable or solvable just by all people dying off, right? But I think a useful product of this discussion, doesn't have to be done in one day, will be that people who really care about this get together to some virtual forum and write this requirement document, if you will, for the next mode, for future mode of scientific publishing. And it may not come to anything, but at least we can have problem defined in a way that's approachable.
Yeah, there's a thing called Force 11. That's Lee Dirks was part of that, actually. That looks at that for all science. And
can I cut off your discussion there right now? We're going to have one last comment from the floor, and then you three can sum up or whatever you want to do.
I just wanted to say this has been a problem across a lot of the disciplines, and make the comment that there are people who've been working on issues of credit and metrics and impact factors for journals and sort of alternate methods for counting that. And one of those groups is altmetrics.org, and there's another group that just launched called Total Impact, and they come out of the gene sequencing world. But if you're concerned about that, you may want to look into those two groups.
Okay, thanks. So, up to the panel, sum up or propose the way forward.
All right.
Which you sort of done.
Me? Okay. All right. First, the metrics are being worked on a lot. The how to do nano publishing and get credit for it is a typical topic of conversation at a general meeting for the future of scientific publishing. I was at 3 of them last year. They happen all the time. Force 11 is a buzzword. Type it in and find the web page. They'll have another conference sometime next year. I guess the metrics of use and citation are the most useful ones. I have a new citation metric on AstroPH this morning, so I have to say that citations really are still very useful. We're developing new publication methods all the time. That's what HESARC is. That's what the Space Telescope Archive is. It's what the archive is. It's basically what CDS is. It's what ADS is. It's what the astronomy software library is. The astronomy software library is linked to by ADS just the same way that the Space Telescope measurements are linked to through ADS, through papers, through paragraph descriptions. People think in words, so that describing things in words is probably the least common denominator to get everything all working together. Otherwise, you don't really need to invent that much stuff. You have to use a lot of the stuff that's there. Up to nano publishing, which is not a solved problem anywhere. There's no real reason why astronomy would solve it.
Right. I just wanted to repeat the question that I just threw. So I wanted to find out what would be the minimum we can do. And I volunteered to, be your assistant to make that happen, because my job, the success of my job is not defined by the number of publications with my name as the first author on a physics journal. That would be a failure at Microsoft. I'm supposed to assist you to do better science. So do let me know and take advantage of what we can do for you from here. And give me suggestions.
Seems to me that we're fairly ignorant of serious thought that has gone into this in other fields. And maybe what we need is a one-day workshop where we can get mutually informed with people from other areas, and then construct that requirements document and start thinking what's already in hand, because some things may require only minor tweaks, as Michael just described. And I suspect it will boil down to the sociological change of getting used to give people credit for things for which they're not getting credit now.
That is the major issue. It's tenure decisions, it's old farts who don't view having software that's used in 10 different scientific papers as important as writing one of those scientific papers. It's the same problem with instrumentalists also, who do things that other people use rather than they use themselves. That's a real serious problem for pretty much everybody in this room.
So we should find the venue that we can reconvene ourselves. Perhaps eScience in Chicago would be a...
Too soon.
Too soon?
We have to organize this and think about it.
Don't mean to be too pushy, but we have to make it happen.
Can I suggest actually
be pushy.
We do continue this conversation online somehow. I suggest a wiki rather than Facebook, but whatever suits you best.
Absolutely.
Yeah. Things you put on Facebook are broadcast to other places.
Yeah, I think a wiki format's I think
whereas wikis are not.
Let's discuss that on the wiki. Okay, let's thank the panel. There's been a great discussion.
Thank you,
the panel, and thank you.